Bismillahirrahmanirrahim. This is a Jeopardy on the points of concurrency of the four important lines in the triangle. And the answer choices here are going to be only four: the circumcenter, incenter, centroid, and the orthocenter. And I believe we have 12 questions. Ready? Okay, let's do it. Bismillah. First question. We'll give 5 seconds or so. You can always pause if you need more time. 5 seconds or so to answer the question. Ta-da! This is the incenter, of course. It is the center of the circle that is inscribed in a triangle. And the incenter is a result of the intersection of the angle bisectors. Okay, ready for the next one? 5, 3, 1. Ta-da! Okay, this is the circumcenter. It is the intersection of the perpendicular bisectors, and circumcenter is, of course, the center of the circle that circumscribes the triangle like you see before you. All right, let's do it. Okay, let's see. What do you think here? It looks like each of these lines is bisecting the other side over here. You can't assume that these are perpendicular. This is the centroid. Centroid is the intersection of the medians. There's no suggestion here in the diagram that any of these are perpendicular, so you can't assume anything other than that's given. You are given that there are medians, therefore that this is a centroid. Now, centroid, by the way, is 2/3 the distance from the vertex. So if this is x over here, this would be 2x over here, right? If this is a over here, this would be 2 times a over here, like that. So that is another property of the centroid. Okay, what do we have here? All right, this is the incenter, point of intersection of the angle bisectors, and that gives you the incenter. The incenter is equidistant from the sides of the triangle like this, because from the angle bisector theorem, we know that every point on the angle bisector is equidistant from the side of the angles, and therefore this point would be equidistant from all 3 sides. How about this one? Okay, so this is the circumcenter. The circumcenter is equidistant. It is the only point that is equidistant from all 3 vertices of a triangle. And it is the point of intersection of the perpendicular bisectors like this. Okay, and it's the radius over here that I'm drawing of the circle that's going to circumscribe this triangle. That is the circumcenter. Ready? Next one. Okay, these are perpendicular lines. You're not told that they're bisecting anything. This is the orthocenter. Orthocenter, again, is the intersection of the altitudes. Okay. Okay, what do you think? Did you say it is the circumcenter? Circumcenter. These are the perpendicular bisectors, and the point of their concurrency is the circumcenter. Every point on the perpendicular bisector is equidistant from the endpoints of the segment. So if this is going to be like this, that's going to be equidistant from that, and that point also is going to be equidistant from that vertex, and that's the radius of the circle that's going to circumscribe this triangle over here. Circumcenter. Okay, how about this one? As I said, I think we have 12 questions. 1, 0. Okay, now this point is equidistant from all sides of the triangle, right? This is the incenter because it's equidistant. Every point that's on the angle bisector is equidistant from the sides of the triangle. So this is the incenter. Okay, how about this one? Again, this is the incenter because this is the intersection of the angle bisectors. Every point on the angle bisector is equidistant from the sides of the triangle like this, and that's why it is the incenter. It is the center of the circle that is inscribed in the triangle. All right, how about this one? Number 10. 2. Okay, did you say the orthocenter? That would be wrong. This is the circumcenter because it is the intersection of the perpendicular bisectors. The point of concurrency of the perpendicular bisectors is the circumcenter, and this point is equidistant from all the vertices, because every point in the perpendicular bisector is equidistant from the endpoints of the segment. So this is the circumcenter. Okay, number 11. Now the triangle in question is the one that's highlighted dark over here, and these are perpendicular lines from each vertices. This is the orthocenter. Now this line is right here. Okay, so this is the altitude for this side. Okay, so these sides had to be extended a little bit to find this orthocenter. But the answer is this is the orthocenter. It's outside this triangle. 4, 3, 2. What is this? These are perpendicular bisectors. It looks like the point of concurrency of the perpendicular bisectors is the circumcenter. That is correct. And that is it. If you enjoyed it, if you learned something, you've done well. Until next time, as-salatu was-salamu ala rasulillah, walhamdulillahi rabbil alameen. Assalamu alaikum.